This week on the show, we review the information everyone has been looking for about Spectre and Meltdown thus far for the BSDs. We look at NetBSD's memory sanitizer progress. We also check out Postgres on ZFS and show you a bit about NomadBSD in this week's episode of BSD Now. BSD Now, episode 228, The Spectre of Meltdown, recorded on the 10th of January 2018. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we have a great show prepared for you this week, because unless you haven't been living under a rock for these last 2 weeks or have been on a tropical island without internet, you haven't heard about the latest flaws in computers called Meltdown and Spectre.
Yes, and it turns out computers were a bad idea.
Yeah, at the beginning it was total failure and people that didn't like it. But we have to live with it now, and we should cover the BSD side of it a little bit. And we should start with the actual first one, the Meltdown attack. This is the official site that we have here, the meltdownattack.com. So what's this about for people who have really no interest or no idea what this is all about?
Yeah, so basically the Meltdown and Spectre are exploit against critical vulnerabilities in many modern processors. They're hardware vulnerabilities that allow programs to steal data which is currently processed in the computer. So normally, in the operating system, when you're in user land, you can't read the memory from the kernel. It's isolated and supposed to be protected by the hardware. However, in the Meltdown vulnerability, because of what's called speculative execution, where when the code reaches an if statement, it might actually try processing both possibilities and doing the next couple of instructions, and then once it reads the variables in from memory or whatever and compares them and figures out which one's the right one, it can, uses the results it's calculated for the right one and throws the wrong one away.
Yeah, that's the branch prediction.
Yeah. However, if you end up with a fault, because one of the things you're trying to read is actually in memory you're not allowed to look at, it cancels the speculative execution. However, that execution might have read data which is now in the cache in the processor. Then from user land, by trying to read that data, and data isn't in the cache, by looking at the amount of time it took, you can tell whether the data is in the cache or not. And this eventually could allow you to read data that you're not supposed to be able to read by trying to read it, failing, but the speculative execution loaded it into the cache, and then by looking at the cache, you could find out information that wasn't there. As the best analogy I heard was, imagine you go to the library to borrow a book, and they have the regular collection, and then they have a special, invite-only or members-only collection of books that regular people can't borrow. But what you do is tell them, I want these two books, one from the secret collection, one of the normal ones. And they go and get both and come back, and then as they're scanning them to check them out to you, they notice, hey, this one you're not allowed to have because you're not part of the exclusive club or whatever. So it goes on the cart to be put back on the shelf. But you also decide, I don't want the other one either. Book? Yeah, the regular book either. So it goes back on the shelf. And then you're like, actually, what I want is the book where the first letter of the first word in the book is this. And so they go and check the main collection and the other collection and find those and bring them back. And then, oh, you're not allowed to have it. And then you say, I want the book that says letter A. And they look and, oh, I don't have to go to the shelf to get that. It's already on the return card. And by doing this iteratively through every possible one, you can read an entire book out of the secret collection by just asking the librarian to go and find the book in the regular collection that has, the fourth letter is the same as the one in the secret book, and the fifth letter is the same as the one in the secret book, and just keep doing that until you've read the entire book.
Oh yeah, that could work as an analogy.
Yeah. So there's the two different vulnerabilities, and they affect different processors. So far, it seems the Meltdown one only impacts Intel processors, but the Spectre one affects a number of different processors
and architectures. Yeah.
Yep. Including ARM, AMD, Intel, etc.
Yeah. Yeah. So the little electronic brain that you have is in any kind of way, or the last 3 or 5 generations of CPUs.
Well, so in particular, what it says here is which systems are affected by Meltdown. It says desktop, laptop, server, and cloud computers could be affected by Meltdown. More technically, every Intel processor which implements out-of-order execution is potentially affected, which would be basically every processor since 1995, except for Intel Itanium and certain Intel Atoms from before 2013. So far, they've successfully tested Meltdown on Intel processors going back as early as 2011. Currently, they've only verified that this works on Intel processors. At the moment, they're not sure whether AMD processors could be vulnerable. And according to ARM, there are some processors that are affected by Meltdown and some that are not. If I remember correctly, the ThunderX 48-core ARM server is not affected, but the ThunderX 2, the 96-core version, is affected. And there's a link to more information from ARM there. And we'll talk a little bit more about ARM stuff in a minute. And then to answer the other question, which systems are affected by Spectre? It says almost every system is affected by Spectre, including desktops, laptops, servers, cloud computers, smartphones, embedded devices, IoT, etc. More specifically, all modern processors capable of keeping many instructions in flight at once are potentially vulnerable. In particular, they've verified this on Intel, AMD, and ARM processors. So probably almost every processor you have.
Yeah, there's no making it look good. It's pretty much affecting everyone who has an electronic chip in within reach of a computer. It's bad, but there are ways to solve these, or at least people are working on mitigating those.
Yep. They also say cloud providers which use Intel CPUs and the Zen PV paravirtualization without having patches applied are also vulnerable. And cloud providers without real hardware virtualization, such as ones that rely on containers that share one kernel, such as Docker or LXC or OpenVZ, are also affected. So quite a bit of stuff is affected.
Yep.
And there's more information, and there's, in particular, the Spectre one is actually 2 different methods or variants. There's variant 1 and variant 2, and then variant 3 is the one that they called Meltdown. They also have some videos here showing it managing to steal passwords from a machine and so on.
This is the actual attack that people are would try out in the wild if they would exploit those.
The biggest reason why it's so such a big deal is there are already proof of concepts towards being able to exploit this from JavaScript running in the browser, being able to steal kernel memory or any memory on the system that might contain passwords and so on. In which case, that it breaks a fundamental understanding of how computers work in that, the userland is not supposed to be able to read the kernel memory that way. But it turns out the enforcement done by the processor doesn't quite work the way we hoped. Interestingly, also, apparently some NVIDIA GPUs are also affected by the same issue. So on the meltdownattack.com website, they have links from Intel, ARM, AMD, RISC-V, NVIDIA, Microsoft, Amazon, Google, Android, Apple, Lenovo, IBM, Dell, HP, every other vendor.
And for people who want to look at the research papers or how people came up with that, they can find those on the webpage as well. There's also a bunch of stuff happening in light of when that revelation has been done, in one way or the other. There is an interesting story behind that, how it got out in the open.
Yes. One of the other parts of the stories is, so Google's Project Zero found this issue in June or July, basically in the summer of 2017, and reported it to Intel, AMD, and ARM. And eventually they came up with a coordinated disclosure date that was supposed to be January 9th, or yesterday from when we're recording this. But a number of things happened, and it ended up leaking out early. Also, interestingly, another group of researchers independently came up with almost the same thing during the embargo time. But one of the other things we learned is that none of the BSDs were given the 6 months advance notice that some other places like, say, Apple and Microsoft and Linux were given. In the end, I think FreeBSD got about 11 days of notice.
Yeah, a little bit
more than everybody else.
Short.
That was only because some companies that use FreeBSD yelled very loudly at their vendors about not notifying FreeBSD and made sure that FreeBSD got notified.
But
otherwise,
we're happy that these people... Yeah. So we got the information, but we couldn't come up with a solution yet because of the short time frame between notification.
Right. Everybody else has had 6 months to work on this, and we've had like 12 days. Well,
and these aren't
that now.
And these things take time. They need to be tested. I mean, they affect pretty much all the architectures FreeBSD or the BSDs run on. They need to be evaluated and also make sure that they have no side effects of other things that might impact these. And so it takes some time to make this work, and the time is now short because the exploits are out there, or the instructions how to exploit this are out there. So people need to make sure that they have the latest patches. But we should get on in our show notes, because this pretty much covers the rest of what we have when we're getting ahead of ourselves.
Only a bit. So we have the Register article that kind of updates us and basically says a fundamental design flaw in Intel's processor chips has forced a significant redesign of the Linux, Windows, and OS X kernels to try to defang this chip-level security bug. Programmers for operating systems are scrambling to overhaul the kernel's virtual memory system and come up with something what's called PTI, or page table isolation, so that memory mapped into the kernel and memory mapped for userland do not can't both be mapped at the same time, basically, so that providing more protection so that userland applications cannot read kernel memory, and using specific processor instructions to make sure that everything stops here and we're switching modes and make sure that data doesn't leak back and forth.
Yeah, what we also didn't mention yet, because people are like, what's the big deal? Just apply the patches and nothing is as it was before.
So they say, critically, these updates to operating systems will incur a performance hit on those processors. The effects are still being benchmarked. However, we're looking at a ballpark figure somewhere between 5 and 30% slowdown, depending on the task and the processor model and a bunch of other factors. More recent Intel chips, which have a feature called PCID, which is, my understanding, is a way for the operating system to tell the processor about the fact that this is this process and that is that process, to try to keep them apart, can reduce the performance hit, but the mileage may vary. On FreeBSD, PCID has been around since 2013, so it's relatively mature, but all the rest of this page table isolation stuff is still under construction.
Yeah.
based on a benchmark that the register points out here, using a Postgres select query, even just select one, so it's not actually having to read the disk at all, with the kernel page table isolation patches for Linux installed, resulted in a 17 to 23% slowdown. Because every time you make an extra syscall, it's going to have to do this dance to change the page tables around to make sure that username can't read the kernel data.
Yeah. So when you get the patch, you're secure from these vulnerabilities, but your systems will be slower than that. And then that's a trade-off.
Maybe over time we can lessen that impact. And there are other things coming, including microcode updates. Although so far it looks like all those do is add additional functionality to make this work stronger rather than actually to solve performance problems. In general, microcode updates solve problems. They don't make anything faster.
Yeah. So people should be aware of that they should apply the patches when they're out, but then they will notice a certain slowdown in certain applications or in their general computer use. Yeah, that's the deal thus far. Yeah,
there's still a lot of work going on in this area. There's talking about things like the return trampolines and adding extra features to compilers in order to make the code harder, cooperate with the fixes better, and so on. One of the bigger impacts is the problem with shared systems. In particular, things in the cloud, where without these patches, it could mean that one VM running on the cloud provider could actually read memory from the host system, which would contain the memory of all the other VMs running. I mean, you could steal passwords and secret keys and other data from any other virtual machines that happen to be running on the same physical machine. And that's why cloud providers have been scrambling to apply the patches and other mitigations in order to make sure that their data running in the cloud isn't exposed.
Yeah, this would be a worst case scenario.
Yep. So then Intel has their official response. Intel responds to security researcher findings, and they're like, hey, it's not only Intel, and some information. To which the register responds, where they say, we translate Intel's crap attempt to spin its way out of this CPU security bug. And there's some, for each of the main points Intel makes, the register has a translation, which are funny to read. There's also a PDF from Intel's security team, or their analysis of the speculative execution side channel attacks. So there's more technical detail in there if you're interested, and what the related security features available on Intel are, including the SMAP, or supervisor mode access prevention, that's supposed to help stop some of this. There's, of course, an XKCD to explain it all to you.
Yep, with the alternative picture as well.
Yep.
So this very high level view, but it's still there's some grain of truth in there as always.
I love the alt text, this one.
Yeah.
New zero-day vulnerability. In addition to row hammer, it turns out that a lot of servers are vulnerable to regular hammers as well.
And I mean, I've been watching this from unfolding, and I was like, there's certainly a new person at the PR department starting in January, and it's like, it's my dream job to work at Intel, and then this happened, and it's like, oh, what a nightmare to start this. But it can't be helped. It's out there. The mess is pretty much on everyone's table, and we should make sure to fix this as best we can. And I mean, in the open source world, there's a lot of sharing with code and back and forth, patches testing. So there's a great collaboration going on. So this is, and that's also beneficial because many people will see that these fixes are being put into other systems or tested on these to make sure that they don't affect or are not affected anymore. So there's a lot of sharing going on, and that ultimately will hopefully make the fixes put into the systems quicker.
Right. For example, the tool CPU control on FreeBSD that can be used to apply the microcode updates to the processor while the system is running has been ported over to Dragonfly BSD so that you can apply the microcode updates once they're available for your processor to your running system.
Yeah, so this is the kind of collaboration we want to see, even though everyone is working in their own little gardens and making sure that doesn't get any specters or meltdowns.
Yeah. So next we have the response from the FreeBSD security team. So this is a message sent to the FreeBSD security announce and notification lists by Gordon Tetlow, saying, by now, we're sure most people are aware of the Meltdown and Spectre attacks. If not, you can head over to meltdownattack.com to read for an overview. And if you want additional technical details, they're available from the Google Project Zero link, also provided. The FreeBSD security team was notified of the issue in late December, so, right before Christmas. Merry Christmas to the security team. And received a briefing under a non-disclosure agreement with the original embargo date of January 9th. Since we received relatively late notice of the issue, our ability to provide fixes is currently delayed. So in particular, Meltdown, in terms of priority, the first step is to mitigate against the Meltdown attack, CVE 2017-5754, which is cited as variant 3 in the Project Zero post. Work for this is ongoing, but due to the relatively large change needed, this is going to take a little while. We are currently targeting patches for AMD 64 being dev complete this week, with testing probably running into the next week. From there, we're hoping to give a short bake time and then push it into the 11.1 release branch. However, additional work will be required to bring this mitigation back to the 10.3 and 10.4 releases. This code will be selectable via both tunable, which will automatically turn on for modern Intel processors and off for AMD processors, since they're reportedly not vulnerable. Since the fix for Meltdown does incur a performance hit for any transition between user space and kernel space, this could be rather impactful depending on the workload. As such, the tunable can be overridden by the end user if they're willing to accept that risk. And then the initial work is being tracked at D13797, which I have a link in the show notes here, in the code review system on FreeBSD if you want to keep track of that.
Yep, that's the work in progress.
And it says, please note this is a work in progress and some stuff is likely to be broken at times. And then secondly, there's the Spectre vulnerabilities, CVE 2017-5753 and 5715. When it comes to the Spectre vulnerabilities, it's much harder to sort these out. Variant 1 is going to require some static analysis to determine vulnerable uses that will require barriers to stop speculation from disclosing information that it shouldn't. While we haven't done the analysis to determine where FreeBSD is vulnerable, the number of cases here is supposed to be very small. Apparently, there have been some covariety rules developed to help look for these types of cases, but we're still evaluating what can actually be done about it. For the other half of Spectre, the variant 2, it's a bit trickier as it affects both normal processes and Beehive. There's a proposed patch for LLVM that introduces a concept called the ret poline, which is a return trampoline, which mitigates this issue. We are likely to pull this into head and stable 11 once it hits the LLVM tree. Unfortunately, the currently supported FreeBSD releases are using older versions of LLVM, which we're not sure if the LLVM project will actually produce patches for those or only for the head version, basically. We'll be looking at the feasibility of backporting those patches to those earlier versions. In addition, there are CPU microcode fixes coming out that in concert with the OS changes would also help, but there's we're not sure exactly when those will be available. Some of them seem to be kind of available on random places on the internet, but we'll see.
Yeah, we can't just trust some certain. We need to test those in
yes. And make sure you get the right ones for your processor and so on. If anything significant changes, Gordon and the rest of the FreeBSD security team will make additional posts to clarify as the information becomes available.
Yeah. So now people are totally afraid, but there's light at the end of the tunnel, and it's not a train. So in this next article, we mention, or we have a write-up by the Raspberry Pi folks, why Raspberry Pi isn't vulnerable to Spectre or Meltdown. So this is from Eben Upton himself, who pretty much started the Raspberry Pi project. So this is a write-up where they describe also what the problem is. So they begin a little bit what scalar processes are versus what a superscalar process is, and this way they walk through the whole idea of what the problem caused initially and why the Raspberry Pis, the little microcomputers, are not affected because they use different architecture, because they have
in particular
processes.
It says both vulnerabilities exploit performance features, caching in speculative execution, common to many modern processors, to leak data via so-called side channel attack. Happily, the Raspberry Pi isn't susceptible to these vulnerabilities because of the particular ARM cores that they're using. And they have some example pseudocode showing how it works, or in this case, doesn't work.
Yeah, so the little microcomputers are they're good for something even before that came out. So if you're really paranoid about this, you might as well migrate to your little Raspberry Pi that you have and work on these before any major patches are being released. So this next one is the Zen mitigation patches. So this is over at the Zen project mailing lists.
Mm-hmm.
And they have a little patch there. Well, it's actually not that little. But they have pretty much written down their own version of the whole events, which we pretty much covered thus far.
They're saying in particular, in addition to this set of software fixes, you will also need a compiler that understands the new indirect branch and indirect branch register flags. A GCC patch series implementing this will be available shortly. I think LLVM as well. And you'll also need the new microcode from Intel and AMD as they provide new machine registers for Zen to use and to virtualize for the guests to be able to use.
Mm-hmm. Okay, and now if you're really confused about which exploit works on which architecture and in which variant, there's a little overview of affected FreeBSD platforms and architectures over at the FreeBSD wiki, where they have some colors here to show you which processor architecture and microarchitectures are affected by which individual of the three exploits we mentioned is vulnerable and which not. And this pretty much gives you an overview whether your specific CPU and your FreeBSD system is affected.
So basically, AMD and Intel are both vulnerable to the Spectre, both types. Although currently it doesn't seem that AMD is vulnerable to the Meltdown, but Intel is, but mitigation work is in progress. The Cavium ThunderX is not vulnerable to any of the three, but the ThunderX2 is vulnerable to Spectre, but not Meltdown. One of the Qualcomm Falcor processors is known to be vulnerable to the Type 2 of Spectre. The Cortex A35 and A55 processors for ARM are not vulnerable, but the A57, A72, A73 are vulnerable to Spectre 1 and 2, although work in progress on the Spectre 2 mitigation is progressing, and they're not vulnerable to Meltdown, but the Cortex A75 is vulnerable to all three, and there's work in progress on the Spectre side. And then hopefully the finished Meltdown work in progress, when it's done for AMD 64, should be relatively easy to apply to ARM 64. And then the ARM v7, so the 32-bit ARM, the A5 and A7 are not vulnerable. but the A8, A9, A15, and A17 are vulnerable to Spectre, but not Meltdown. And it seems Spark 64 and RISC-V are not vulnerable to any of it. And PowerPC is still being assessed, but Power 6 does not appear vulnerable to Meltdown.
Yeah, that's the state of the mess we're in right now, and we'll keep this page updated as more things are being
In particular,
developed.
the empty cells are information that's not known yet. Or if your processor is not listed on here at all, it's because we don't know yet.
So the whole vulnerabilities got the attention of a certain goat, which we have a little tweet of here. So it's just saying, I'm a little afraid to tweet because of the Meltdown and Spectre attacks. So yeah, this is certainly something everyone has to deal with in one way or the other, whether it's an end user or we as operating system developers a little bit more. And I mean, this is CPU code. This is way in the innards of the kernel and the operating system. This is certainly requiring a certain amount of knowledge about the architectures and the microcode. And well, this is certainly not something you would do as a weekend project as a beginner.
Yeah.
But we're grateful to have these people.
Mm-hmm.
And
we'll obviously have more coverage on this next week, in particular covering the OpenBSD, NetBSD, and Dragonfly BSD responses, of which there already are some, but we...
the show would be too
producer had
big.
A cold, and it's been difficult to write all the notes and understand all of this to try to present it to you, as you might have tell by slightly, subpar coverage. We'll be recording next week's episode early, so it won't be long. Don't worry.
Yeah. So each project is also handling it in their own way, which doesn't say it's good or bad. It's just their own way of handling these things, and we'll cover this in the next episode, because otherwise this one would explode with just these two exploits. And we have some other stuff to report to you.
Yep. This week's episode of BSD Now is brought to you by IX Systems.
Yeah, head over to ixsystems.com /BSD Now. And there you will find your server buying guide for open source, because there's a new year and you have a new budget maybe as a company or even as a private person. You think, I always wanted to have that server I was dreaming about, or we have this new project in the department that should have a great open source lineup and software, but it also needs great hardware that supports that. And IX Systems are the folks that can build you exactly that system that is the perfect match for your software needs in the open source world. So let's say you're building a backup server, then IX Systems can certainly build you a beefy machine that has a lot of storage and uses ZFS file system, of course, to make your backups secure and readable even in 100 years if you require that far. So IX Systems are the people who also know which components work best for you. So in case you want to have less, you're figuring out, I need more memory because I'm running more memory-hungry application, then they can tell you a certain performance benchmark that you definitely achieved with certain components. Because IX Systems has built pretty much thousands of different configurations of these systems, and they know what the specific specs are of CPUs, memory and hard disks to make them all work together to deliver you a system that is performant and beefy enough for your needs. So they don't give you a system like from the shelf, but they will build you a system specific to your needs. And pretty much everyone's need is a little bit different. So they, if you give them a call, they will certainly ask you for what kind of intended purpose the server should serve, and then they will build you a system that's required or that's tailored towards that specific need. IX Systems is also a big supporter of open source projects and FreeBSD conferences,
including
particular.
FreeNAS and TrueOS, which they maintain the staffs for and get working, and They're sponsor at all the conferences. They're an important part of the community.
Yeah, so they get in touch with the developers, and there's a lot of sharing back and forth. And if you're a home user, you might want to check out a FreeNAS Mini or a Mini XL, which is a little backup server you can have running in your basement or in the corner somewhere. And this is the new solution for your backup needs. And it's extendable. If you need bigger hard drives, you can swap them in and exchange like your 1 terabyte drives if they aren't big enough anymore with 2 terabyte drives. And the ZFS that's built into or running basically your FreeNAS system will pick this up, and slowly you can migrate your pool to a higher version of your hard disks. So yeah, check out IX Systems, their whole website. They have also a configuration utility, so you can click your own server of your dreams together. And yeah, give them a call if you're interested in an open source server solution, and they will build you the system to your own purposes. All right. Next up, we have a new story from the NetBSD folks about the LLVM memory sanitizer support. They have work in progress there, and they wrote an update on the NetBSD blog about this.
Mm-hmm.
Apparently, in the past 31 days, this blog post begins, I've managed, so this is from Kamil Rutarovsky, so he managed to get the core functionality of the memory sanitizer to work, or MSAN. This is an uninitialized memory usage detector. So if you have memory that's uninitialized, this will be detected, which is not this is a bad programming practice anyway. So this one can detect these errors in the programs. So MSAN is a special sanitizer, he writes, because it requires knowledge of every entry of the base system library and every entry to the kernel through public interfaces. And this is a mandatory in order to mark the memory regions as initialized. So most of the work has been done directly for the memory sanitizer, but part of the work helped generic features in compiler RT. So there's a bunch of sanitizers available, or at least in this case, the changes in the sanitizer that are listed in this list below are pretty much the one they already worked on. So almost all of these changes they mentioned there landed also in NetBSD upstream, and a few small patches were reverted due to breaking of non-NetBSD hosts, and are rescheduled for further investigation. They maintain these patches locally and have moved on for now to work on the remaining features. So you can see that there's a lot of function calls being renamed or moved to other versions of these. They also, in particular, made some more changes for the POSIX-specific parts. As you can read up on these a little bit further down in the listing. They also did some more work in the NetBSD syscall hooks. So he wrote a large patch of 815 kilobytes. That's a lot. It doesn't sound much, but if it's applied, that's a lot of code changes. So adding support.
That's all text. Mm-hmm. And so a kilobyte of text is 1,000 characters.
Yeah. So this is certainly significant. So this patch adds support for NetBSD syscall hooks for use with these sanitizers. And the description there is that the implemented the initial set of NetBSD syscall hooks for use with these sanitizers. Whoa, I'm also insane in some way. So they added a script that generates the rules to handle syscalls on NetBSD. The generate NetBSD syscalls awk program has been written. It has been in NetBSD awk. They patched that NAWK. And this is compatible with GNU AWK. And they generated lib sanitizer common, so this is the full path. So this is that the public header for these applications are included. And you can see here's a small demo down here with the program of the 815 kilobyte patch we mentioned. And you pretty much see that when you run this small program, it checks for these uninitialized memories, and in the output down below you can see that you get an error because the address sanitizer figures out that there's a stack buffer underflow on a specific address, and that will notify you of the problem, and you can also see a little diagram of how the memory looks like and where the actual error is occurring. So this is the output from the sanitizer, which is kind of nice if you're doing a lot of memory allocation and deallocation. And so this is
and make sure that you're not touching things you're not supposed to or leaving things behind. Also, similar to the syscall hooks, there needs to be a set of IOCTL hooks for every call. They've created another patch, this time a little bit shorter, only 300 kilobytes of code.
It's still a lot.
And it's pending review upstream. Introduce handling for 1,200 NetBSD specific ioctls. Over 100 operations are currently disabled as unavailable or having conflicting with some other existing one because of the same operation number. Added a script that generates the rules to detect ioctls on NetBSD. This generate NetBSD ioctls.awk script has been written in NetBSD awk and is compatible with GNU awk.
There's also 2 new patches still pending for upstream review. So there's one for adding mSanitizer interceptor to fstat, and also to correct the set timer interceptor on NetBSD.
I think it's set iTimer, but yeah.
Oh, set iTimer. Oh, the I was so small that
They've also had to rename a few functions in NetBSD's code, including one function called uname in PS is renamed to USR name, since it's about usernames, not Unix name. Removes a name clash with libc. This situation is legal in the C language, but unwanted in the POSIX environment and makes it harder to reuse the sanitizer and other code. They removed 3 unused and unimplemented legacy syscalls, SSTK, which is the stack section size change, SBRK, which is change the data segment size, and vadvise for specifying system paging behavior. The sbreak syscall could be removed as the functionality is implemented by BRK in libc in assembly on NetBSD. They also detected and corrected a bug in the pipe2 syscall, as it was returning incorrectly 2 integers instead of 1 with the status of the operation. This was left over from the pipe syscall behavior and implementation details. They've introduced refactoring to address this and to make the code cleaner.
Mm-hmm. Very nice. So they have plans for the next milestone. They plan to continue to work on the memory sanitizer and correct sanitizing of the NetBSD base system utilities. This mandates that they iterate over the base system libraries, implementing the missing interceptors and correcting the current support of the existing ones. And the milestone is to build all programs in /bin against the memory sanitizer, and when possible, execute them clearly. And if you're interested in this work, this is sponsored by the NetBSD Foundation and is made possible through donations to the NetBSD folks. And if you want to support this work, then consider a donation to the NetBSD Foundation. So after you huddled under your blankets from the Spectre scare that we gave you in the first part, we are now going to our news roundup this week. Starting with a little lighter note from Michael W. Lucas's 2017 wrap-up. So he made plans for 2017 and 2016, and you can find this on his 2016 wrap-up post. And here in this blog post, he pretty much looks back and see how the year went for him in his life and his writing in particular. So this is what we're having here in this blog post. So it starts with, it's that time again. Time to reflect on my myriad personal failures in 2017. The obvious place to start is his 2016 wrap-up post that we linked here, where he listed his goals for 2017. So as usual, he writes, these goals were wildly delusional. The short answer is, my iron was back to normal. My writing speed wasn't, though. I'd lost too much general health and needed hard exercise to recover it. Yes, writing requires physical endurance. Maintaining that level of concentration for several hours a day demands a certain level of blood flow to the brain. I could have faked it in a day job, but when self-employed as an artist, not so much. Then there's travel. I did my usual BSD CAN trip, plus 2 educational trips to Lincoln City, Oregon, The current political mayhem convinced me that it was that if I wanted to hit EuroBSDCon anytime in the next few years, I should do it in the very near future. So I went to Paris, he writes, where I promptly got pickpocketed. Yeah, Alan and I were within meters of him, and it could.
Well, I wasn't. I was on a different train.
Really? You weren't with us? So I was within arm's reach, and it's pretty much you get off the train and it's like, where's my wallet? And we were like so close together, and bad situation, but we figured it out. He got back in time, and all in one piece. So yeah, thankfully they didn't get his passport. That was luck in this bad situation anyway. So he continues to write. I was actively writing the 3rd edition of Absolute FreeBSD. So he visited BSD Chem in Cambridge to get the latest information and a sense of where FreeBSD was going. And he also did weekends at Kansas Linux Fest and PenguinCon.
Yeah, and he says, because people will ask, why did I go to Asia or EuroBSDCon instead of AsiaBSDCon? Well, a 6-hour transatlantic flight requires that I take a substantial dose of a heavy-grade tranquilizer. I'm incapable of making intelligent decisions while on those drugs, or for several hours afterwards. They don't last long enough for a 12-hour flight to Japan. So I need to be accompanied by someone qualified to tell me when I need to take the next dose partway through the flight. This isn't a predetermined time that I can set an alarm for. It depends on how the clonazepam affects him at those different altitudes. A drug overdose while flying over the North Pole would be bad. When I can arrange the qualified companion, I'll make the trip. Mm-hmm. He says, I need most of the preceding weeks to prepare for long trips, and I need the following week to recover from time shifts and general exhaustion. Additionally, I have to hoard all my people juice for a few weeks beforehand so I can deal with folks during these expeditions. Travel disrupts my dojo time as well, which impacts my health. Taken as a whole, I don't get nearly as much done as I had hoped. So he has a picture of his complete output of big books, which are Git, Commit, Murder, and the Relay D Mastery book. Or everything I put out, which was 1 novel, 1 tech book, 1 story, and 1 novella. So that adds the Taken by System D, or what? Seduced by
Savaged by System.
Savaged by Systems D book, and another book I can't quite see the title of.
He mentions that in the text coming up.
Okay.
This is Git, Commit, Murder. So these, people, he's like, it wasn't a good year, but some people managed to just finish 1 book, and they hate every minute of that. And so Michael is still ahead of those people. But yeah, if you're an author, this is your output. You have your own expectations for that.
Yes. He said he wrote more stories, but his copy editor bludgeoned him into submitting them to the traditional markets. So while they may not have been published, you did do the writing, which is the hard part, right? So take some credit for that. Among his 2017 titles, his fiction outsold the tech books. No, not the Prohibition Orcs. All 4 of these people who buy those love them, but the sales tell me that I've done something wrong with these tales. His cozy mystery, Git, Commit, Murder, outsold Relay D and HTTPD Mastery. And I know he's working on the sequel. But what outdid them both, as well as most of my older books, what title utterly dominated my sales for the last quarter of the year? It was, of course, my open source software political satire disguised as porn, Savaged by System D, an erotic Unix encounter.
Yeah, who would have thought this would be...
I can't believe I just wrote that paragraph.
He also writes, the good news is, once I recovered from EuroBSDCon, my writing got better. I finished Absolute FreeBSD 3rd edition and submitted it to the publisher. He also wrote the 2nd edition of SSH Mastery. That's not out there yet, so we'll cover that in a future episode. Yeah. He's plowing through Git Sync Murder, which is the sequel to Git Commit Murder, so you can look out for that. I don't get to see the new Star Wars movie until I finished Git Sync Murder, so hopefully that'll be this month. All in all, he wrote 480 and 200 words in 2017. Wow. Most of that was after September. It's annoyingly close to breaking 500,000, but after 2016, scandalous 195,700 words, he'll take it. So one of the nice things about being an author, he writes, is that most of your income is passive. You do the work, and the money trickles in for years afterwards. He had money coming in while he was out of commission. The bad news is that income slowly drops. So if he stays an author instead of becoming a wage peasant again, he has to schlep some books out to PDQ.
Pretty damn quick.
PDQ, yeah. So he can do it, provided he remains focused on production. So that slump is the big reason why he broke down and started a Patreon. So there's a link to his Patreon here. It's why I started taking sponsorship for tech books. You folks carried me through the health problems. I can't thank you enough. The fact that Absolute FreeBSD 3rd edition is traditionally published complicates the financial picture. He won't see any money coming from that book until 2019. So he's not complaining. That's just a fact of life, and he knows what he's going into, but provides extra motivation for getting his butt in gear right off in 2018. So 2018 will be his year of making words. The finest words, of course, artisanal, straight from Detroit, a third world city in America's heartland. So what's on tap for 2018, Alan? What's his plan?
Yep. So obviously he'll go to BSDCan. Looking forward to seeing him there. And PenguinCon, which is his local conference, plus 2 educational trips to Oregon again. But that's it. Under no circumstances will I leave North America. Sorry. His goal is to write 600,000 words, or about 50,000 words a month. And he hopes to complete and release 4 tech books, including SSH Mastery 2nd edition, FreeBSD Mastery, Jails, which might actually turn into 2 books, either Mastodon Mastery or Ansible for legacy systems. I'd vote for the latter one there. And then hashtag Michael W. Lucas's secret book, which I can't talk about for now, for reasons that will become clear once the book actually comes out.
Ooh, excitement.
And his other goals are to write the tech book I didn't complete above and release it if there's time. To write 4 novels, including Git Sync Murder, the sequel to Git Commit Murder, Bones Like Water, which is part of the Immortal Clay series, Drinking Heavy Water, which is part of the Montague Portals series, and to be one other book to be decided from a list of candidates, all of which he really wants to write. He also plans to be sufficiently flexible to be able to kick Ray Percival in the head at BSDCan. While a front kick will do, he's hoping to have the flexibility to do a side kick. He also hopes to exercise enough to drop 20 pounds, stay married while doing all of the above, and also stay alive.
So these are some serious
goals. The last 2, which is to stay married and stay alive, they're all deliberately fail-forward goals. If I only get 3 of the 4 tech books done instead of 4, hey, I'm ahead by 3 tech books. And if I only drop 10 pounds, that's better than gaining 10. But staying married and staying alive aren't fail-forward goals, but I have a good idea how to achieve them. So this time next year, come back and see exactly how I failed.
Okay, so these are some serious plans. And yeah, good luck with these, and all the best for 2018 for you, Michael. And people buy his books. We can't recommend it enough. It's just the greatest tech fiction, or the greatest tech books that I've read, and I learned so much from them. It's
the best crossover. Like, if you haven't read Git Commit Murder, you should. And if you've never been to BSDCan, after reading Git Commit Murder, you'll want to, and you should.
Yeah, so there's a good stuff in there. And I mean, the stuff that's coming up, I mean, I look forward to the FreeBSD Mastery Jails book. He's been at it for a long time. And these other books,
I'm interested what things about Jails I don't know.
That would be interesting, yeah. And yeah, so we'll keep you updated if he has more information coming out. Maybe we'll do an interview in the future about his books. And give him a shout out on Twitter, or buy his books, and that'll make it a long way towards his goal.
Yes. So our next article is Postgres Friday, Postgres on ZFS. So it starts off, ZFS is a file system originally created by Sun Microsystems and has been available on BSD for over a decade. While Postgres will run just fine on BSD, most Postgres installations are historically Linux-based. ZFS on Linux has been much more rocky on the road to integration due to license problems and so on. As a consequence, administrators were reluctant or outright refused to run ZFS on their Linux clusters. It wasn't until OpenZFS was introduced in 2013 that this slowly began to change. These days, ZFS and Linux are starting to become more integrated, with Canonical of Ubuntu fame even announcing direct support for ZFS in their 2016 release. So how can we relatively obscure file system designed by a now-defunct hardware and software company help Postgres? Well, we're about to find out. And each section of this blog seems to be a verse from a song or something.
Yeah, it's... I had it the other day. Well, we'll let the viewers and audience figure this out.
So the hardware he used was an old server that he got dirt cheap, a Dell R710 with dual Intel X5660s, so 24 threads, 64 gigabytes of RAM, and 4 1 terabyte spinning hard drives, an H200 RAID controller configured in HBA mode, so no RAID, which is good, and a 250 gig Samsung Evo SSD. This is using the H200 in HBA mode is particularly important as ZFS acts as its own RAID system. We don't want to use hardware RAID. ZFS also has its own checksumming and other algorithms that make it better. Due to this, we lose out on the battery-backed write cache of the RAID card, but to make up for it, it's fairly common to use an SSD or other persistent fast storage to act as both a write cache and a read cache. So the first thing, we needed a file system. This hardware has 4 1 terabyte drives and a 200 gig SSD. To keep this article from being too long, we've already placed GPT partition tables on all the hard drives and split the SSD into 50 gig for the OS, 32 for the write cache, and 150 for the read cache. A more robust setup would probably use separate SSDs or a mirrored pair of these, but this is just a lab. So he shows the commands he uses to create the mirror of 2 sets of 2 disks. So you have a RAID 10 with a log and a cache.
And A shift 12, important.
Yep. With 1 terabyte disks, they might not be native 4K, and 512 might have been more efficient, but probably not.
No, yeah, I didn't say which kind of disk or what kind of...
Well, it says they're 1 terabyte and they're old, so anyway.
Oh, well, but better than nothing.
Yes. It's a default. And then ZFS tuning, he set compression on, A-time off, and a Linux-specific relative A-time feature on. And then he configures Postgres, setting the shared buffer size to 4 gigs, the work memory to 12 megs, maintenance work memory to 1 gig, etc. And the cache size to 40 gigs. And then he ran the Postgres benchmarks.
Oh yeah, PG Bench. This is a fairly standard PG.
He says, let's start by getting a performance baseline for the hardware. We might expect peak performance at 12 or 24 threads because the server has 12 real CPUs and 24 threads. But query throughput actually topped out at 32 processes. We can scratch our heads over this later. For now, we'll consider it at the maximum capabilities of the hardware. So when run, got about 264,000 transactions per second. But that was all reads. So then he tried some other. So he says, let's repeat the same tests with writes enabled. Once that happens, the file system syncs, dirty pages, the write-ahead log overhead, and so on will drastically reduce the overall throughput. So when he runs it, he got about 6,100 transactions per second. But then he toggled the Postgres setting full page writes. The point of this is to make sure you write the full sector for the write-ahead log so that it doesn't get shorn if the file system the system crashes while it's writing. But because ZFS is already copy on write, you may be doing that work twice. And you're getting write amplification because of the copy on write as well. So by turning off the full page write feature and running the benchmark again, actually got over 10,000 queries per second for about a 70% improvement.
Okay, that's significant already. So this is something people should try out if they have that in production.
In the 1 minute run of pgbench, with the full page writes on, it wrote 1.2 gigabytes, whereas with it off, it only wrote 160 megabytes. So a lot less data getting written because you're not rewriting that last sector multiple times.
Okay, good to know.
I also played with a couple other settings. Astute readers may have noticed we didn't change the default ZFS block size from 128K to align with the Postgres default of 8K. When they compared it, using 8K, the compression ratio was 1.7 to 1, whereas with 128K, the compression ratio was 7.6 to 1. Higher compression when you use the larger block size. If that is what you're after, especially one reason why this actually matters most is we have compressed ARC now, where that compressed data will stay in RAM compressed, meaning more of the data in your database can fit in the RAM. So getting 7.6 instead of 1.7x compression means more of your database fits in RAM. If that's the case, you might actually consider upping the record size from the default 128K to 1 megabyte, meaning you'll get even more compression on that same data.
Oh yeah, that would be good to try out.
You know, more of it staying in RAM that way, if you have compressed ARC. I think Linux does. FreeBSD definitely does.
Yeah, and you have Postgres.
And it says, no, this is not deduplication. This is simple LZ4 compression, which provides near real time in terms of CPU overhead. It's very low overhead. And I'm still progressing on the Z standard compression for ZFS.
Yeah, I was just going to
increases the overhead somewhat, so uses more CPU time, but can get even better compression numbers.
Okay. But we're still not done yet. So one important aspect, right, of ZFS is the copy on write file system, is that it has integrated snapshots. So consider a scenario where a developer is connected to the wrong system and drops what they think is a table in the QA environment, and it turns out that they were in the wrong terminal and just erased the critical production table, and now everything is frantic and your phone is ringing. Yeah, so but we can simulate that by just creating a snapshot and then, you know, drop the table from the PG bench and then, oops. But luckily, ZFS has the clone ability that makes full use of its copy and write nature. And this is pretty much what we know about that this is working. So you can, here's the example, you clone that database first into a new tank/recover data set, and then you have your snapshot in a new data set. It's still not a fully independent data set because you have to promote that afterwards. But for these purposes of benchmarking, that's sufficient. So that disaster was averted by using snapshots and the clones.
And it says, the future is wide open. It's difficult to discount the immediate observable reduction in write overhead. Snapshots have a multitude of accepted and potential use cases as well. In addition to online low overhead compression and the hybrid caching layer, ZFS boasts a plethora of features we didn't even explore. The built-in checksums with integrated self-healing suggests it isn't even necessary to reinitialize an existing Postgres installation to enable checksums. The file system itself ensures checksums are valid and correct, especially if we have more than one drive of resources in our pool. And also gives the extra mile of actively correct inconsistencies when they are encountered. He says, I immediately discounted ZFS back in 2012 because the company I worked for at the time was a pure Linux shop. ZFS was only available using the Fuse driver back then, meaning ZFS only worked through user space with no real kernel integration. It was fun to tinker with, but nobody's saying would use that in production. But things have changed quite drastically since then. We stopped waiting for ButterFS to become viable, and ZFS will probably take the throne away from XFS as our file system of choice. Future editions of the Postgres High Availability Cookbook will reflect this switch to ZFS.
Oh, excellent! Yeah, it's what I always say. I mean, if ZFS had only one feature that is cool, people would be like, yeah, but it has so many, and it's so great, and they all work so well together, and this is just. And people then usually say, Benedict, shut up and do a podcast about this. And that's what I do. So yeah, people who run Postgres on ZFS or are trying to, they can get some starting points here. You also have a bunch of information in your ZFS. And is it the advanced ZFS book that you have?
Yes, although I don't have that much personal experience with Postgres.
Yeah,
but I do have some.
It's a good start.
Basic stuff.
And then people can figure out.
But yeah, after EuroBSDCon in Paris and talking to a FreeBSD user that had SQL databases and was using the larger record size on purpose to get the extra compression because their database was backed all by SSDs and they couldn't afford to add as many SSDs as it would take to store it with the smaller record size because they would get 2x compression instead of 8x. Made me very interested in that concept and taking it further.
Mm. Yeah, so people check that out and implemented their own systems.
Yep. This week's episode of BSD Now is also brought to you by DigitalOcean. Head over to digitalocean.com and check them out. They just issued their New Year's update as well. And they said in 2018, they look forward to dropping a bunch of new types of droplets, so even more sizes to pick from. I've been a big fan of this new $15 one that gives you more memory at a nice price. But they tell us much more is coming. They've also extended the availability of their block storage, so you can have it in Singapore, Toronto, Bangalore, and London, in addition to the New York, which gives you quite a few more options as far as using that. And over the course of 2017, we saw the new high CPU droplets, the price drop on the high memory droplets, lots of upgrades to their network, and lots of other stuff. So, while it's a great offering right now, it's only going to get better as 2018 goes on.
Yeah, so if you need a small server and the internet for all kinds of computing needs, whether it's a blog or you want to play around with FreeBSD a little bit, check out the DigitalOcean folks and use our coupon code FreeBSD Now, which will give you a $10 credit, so you can start this experiment with the $10 credit to get the first experiences and your feet wet with these systems. And then you can say, it's nice, but I should run this other system, and then you just stop the instance, the droplet, and then start up another one, and you only get billed for the runtime of each individual droplet. If you have a bunch of friends that you should also convert to FreeBSD, then you should probably figure out Spaces or the feature where you can collaborate with them.
The teams,
because then you can say, my friends shouldn't look at my builds, but they should be able to, access the system console in case I'm on holidays.
Yeah,
things like that.
A number of useful features for that, whether for business or even just for a hobby group. Like I know one of the droplets we have that runs a Mumble server. We need to make sure that a couple of people have access to the account in case something happens, and it was just very easy to do with the team system.
Yeah, you hide what you don't want other people to see, and you share the rest with your buddies. Yeah, so check out DigitalOcean and definitely use our coupon code. All right. So once in a while, we get mentions of other BSDs out there that we haven't heard about before. And this one we heard about or got sent to called NomadBSD. This is over at GitHub. Mm-hmm. So what is this NomadBSD all about?
It's a live system designed for flash drives on BSD. Mm-hmm. So it actually allows you to build a customized version of BSD on a flash drive that you can run as a live system, but actually with some persistence because it's on a flash drive. So it just needs a 4 gig or larger flash drive and some system capable of running FreeBSD to the original build. So you just download this stuff, run make image, then DD the image to your flash drive. And then you can resize that file system to make it the full size of the hard drive. And it's then run growfs, and it pretty much done.
Oh yeah, this is straightforward. And you can see what it looks like here in these screenshots. So if you needed kind of a rescue system or just a system to show your friends.
A whole FreeBSD system you can just carry around in your pocket and plug into any computer. This seems very nice.
Mm-hmm. Oh yeah, so check out NomadBSD and give some feedback and contribute something, maybe a couple of pull requests.
Yes, looks quite interesting.
I should play around with this over the weekend.
Mm-hmm.
Time for the Beastie Bits this week, starting with Cool Package, a package manager inspired by Nix for OpenBSD. So this is also over at GitHub. So Cool Package is a source-level package manager inspired heavily by Nix. Project goals are as follows. They want to have reproducible builds already. They encourage users to curate their own custom package tree and repo and make this easy. And they want to fork a packaging or a package, and adding custom changes is just a single file copy. You could make a package to patch a package. That should sink in. You could make a package to patch a package. Okay. Mixing versions of packages freely on the same machine. No dependency, however. They also want to have work on FreeBSD/OpenBSD. Different package trees per operating system, so they don't force any abstractions. They're okay to depend on BSD-based systems and compilers. They push self-contained packages to other machines via SSH, even if they don't have Cool Package. And Nix's power just as far simpler in nearly every way.
That sounds pretty cool.
Check out the Getting Started page and try it out for yourself.
It is interesting to have the idea of installing on other machines without having to install the package tools there. Have the tools on one machine and just have it install the packages on the other machines.
That requires Python 3, so that might be the starting point. All right, we'll see. Next up is ZREPL, which is a ZFS replication solution. We get a lot of feedback or asked at conferences, what can I do to do a proper ZFS replication to a separate system in case I delete a snapshot or I have a gap in my snapshots on the remote system. So we get all kinds of ZFS advanced send and receive questions, and ZREPL might be a solution for you.
Yeah, it's a nice tool written by a nice person.
Well,
as you can see from its main feature list, most of the features are actually complete now. It has local and remote replication. It has pull mode. Doesn't have push yet. It has access controls when pulling data sets, flexible mapping rules, bookmark support. Doesn't yet have feature negotiation to figure out, resumable send and receive, compressed run and receive, raw encrypted send and receive, and so on. But those are planned or in the works. Has automatic snapshot creation, so you don't need a separate tool like you do with ZXfer. It supports automatic snapshot pruning. You can do age-based fading, like a grandfathering scheme, so on. It has flexible, detailed, and structured logging, so you can output for humans or long format or in JSON, whatever you want. You can output to standard out, to syslog, or to TCP with TLS certs, and so on. And it's maintainable implementation done in Go, so it's cross-platform, type-safe, and tested.
Yeah, so this is certainly something people should check out. And maybe we should do an interview with that guy because...
yes,
to quote...
We'll just have to tie him down at some point.
Yep. I met him last year at the Chaos Commuter event. And to quote Kenobi, I was already impressed how strong the force is within the... So, yeah. Let's leave it at that and go to our next item. This is an OpenBSD hot plug D auto mount script. Oh, that sounds exciting. With that, you can mount removable USB devices when attached. So this is automatically detecting them. And
so this is like the AutoFS on FreeBSD?
I think so, yeah. Looking at it.
Call it hot plug, but...
Yeah, so this is all done in bin.sh, so basic shell. Figuring out which kind of device was inserted.
Yeah, so if it's a disk device, it uses disk label and reads each line for each one. It detects the file system, whether it's MS-DOS, ISO, ext2, or UFS, and mounts it. And if the type is 3, meaning it's a network device, like a USB Wi-Fi card or whatever, then it runs netstart on that device. Cool.
Yeah. Try this out in OpenBSD and send us a feedback to feedback@bsdnow.tv how it works for you.
Here's the next one. Ancient trough source code versus modern day graph. I've been on a trip on the memory lane recently, digging around old manuals for Unix operating systems before BSD. In doing so, I came across the sources for the 7th edition manuals, so the actual source code for the manual. I wanted to show one part of Volume 2A to other people, but didn't want to make them download the entire 336 pages of Volume 2A for this one part in question. So the part I wanted to extract was Learn Computer-Aided Instruction on Unix, starting on page 107. A normal person, I presume, would split the PDF file. That is straightforward and produces the expected result. I believe I needn't state that you wouldn't be reading this if I had solved the problem that way. I opted to rebuild the PDF from the trough source provided at the link above. I'm not a very clever man, and thus I completely disregarded the generation procedure that was already spelled out. However, I wasn't exactly specific anyway, so I didn't miss out on much. So, getting these sources. So I knew that I needed to do, get the trough source code. I asked that the heavens have mercy on my poor soul if this required a lot of adjustment for 2017 text processing tools. However, a man must do what a man must do. The file in question was called volume2/learn.bun. I had no idea what a bun file was, hoping it wasn't related to steaming buns, and clicked on it. As it turns out, it's just what we would call a self-extracting archive today. The shell commands are not very weird, so I extracted. So the extraction process actually worked out just fine. Now I had files P0 through P7, except what happened to P1, the world would never know. So first up, I've dabbled in man pages before, but that was mostly mandoc, not actually trough. Accordingly, the first attempt at getting something going was as naive as it could be, ran graph type PDF on each of the files and piped it into his PDF viewer. It led to, shall we say, varying results. He says, clearly I was doing something fundamentally wrong. And then he passed some extra things in and it started to look like a book. But he says, allow me to express my doubts that this text was written in 2017. If you compare the output with a known good PDF, you notice that somehow Bell Laboratories, Murray Hill, New Jersey, turned into CAI. Unfortunate. So starts playing with it more, getting further and further, and having lots of fun with it. Anyway, if you're interested in playing with these old manuals and what's required to build them nowadays, you should check this out.
Mm-hmm. Yeah, this is certainly for the man page folks who want to know more about these. Okay, next up is the PayPal donation balance and status from the Dragonfly BSD project.
So this is a post by Matt Dillon. It says, I thought it would be fun to give everyone an update on our PayPal donation balance. Our donation account currently has $7,677 in it, plus another $1,600 in the accompanying bank account. I've been letting it build up for the last few years. We get lots of small donations, typically less than $100 and often just 10s and 20s and so such. It adds up after a while though, and the current balance would allow us to purchase some useful things. However, I don't want to spend it on incidental expenses, which are actually fairly significant. The co-located rack costs us around $4,000 a year, and the Blade server and Opteron boxes were priced in the low 5 figures. But I'd like to spend the donations on upgrades rather than incidentals, so people feel that their donations have had a significant effect. We have plenty of CPUs and memory resources, but storage is starting to be a bit crufty. So we will be spending a chunk of these donations on upgrading the storage on our systems. Right now, the SSDs and hard drives are in excess of 5 years old. Considering that we have almost 30 discrete storage devices, only 3 hard drives have actually failed in the intervening time, and no SSDs, although the firmware occasionally crashes on this one, and it requires a power cycle. Anyway, he says, I think it's time to upgrade, and I will be using the donation money to help with that. We will be upgrading the SSDs and replacing primary hard drive storage for serving our data, home directories, repositories, and such with additional 1 terabyte SSDs. Probably 2 for each of the blade times 12 blades. That's the expensive bit, considering the number of SSDs that we'll be putting in. We'll be ripping out all of the existing hard drives and then throwing in a few 2.5-inch 4 terabyte hard drives to hold the backups and scratch space for certain projects like the grok.dragonflybsd.org. The old SSDs are still in good shape, only the build box has significant wear, and then it's only down to 85% of its life after 5 years. So we will put those SSDs to good use, probably as secondary swap for each blade and for other test boxes that aren't in the co-location. I want to thank everyone for their donations, and we're going to put them to good use.
Yeah, seems like they can make the money really work for the project. So consider donating to the Dragonfly BSD project. Do they have some kind of official link to that?
I think on the Dragonfly website somewhere.
Okay. Our next item that we have is a supervised FreeBSD RCD script for Go daemon, which was updated in the last few days. The short post here. So this one created a FreeBSD RCD script for Go, as I mentioned. To make it more interesting, this daemon will be supervised so that the program doesn't terminate for some reason, or if in case the program terminates for some reason, the Go program will be restarted automatically. The ingredients are relatively straightforward. To start with that, or if you want to implement your own daemon, he recommends reading the excellent practical RCD scripting in BSD. There's a link here.
Article in the FreeBSD handbook.
Yeah, this is pretty much where people can find all the information they need. They're pretty simple bin.sh scripts, as pretty much all the shell scripts should be, not some other shell that's not part of the base system. Not mentioning specifics. So what allows the RCD scripts to remain simple is rc.subr, the framework that takes care of a bunch of
subroutines written in shell that do all the heavy lifting. So you don't have to rewrite it for each program. You just use the existing library of functions.
A little that people have used and written in the past. And so there's also making use of the daemon utility because that can the subroutines can handle most of these use cases, but because we want to supervise the daemon, you need to use the daemon utility, which has a link to the man page here. And down here is the actual script that he wrote. So this is straightforward, setting a bunch of variables at the beginning, and then have a bunch of functions here to call, to start, to stop, and to get the status of the daemons or the program. And then you pretty much run your RCD script.
Yes, so he wrote his own start, stop, and status functions. And then in an update, Steve Wills and other people from FreeBSD in the Reddit discussion actually pointed out that the rc.subr provides all those already. And all he needed to do was set the name of the program and allow the default start, stop, and status to take care of it. So you just
make it shorter.
Yeah, just by setting a couple of variables at the top of a shell script and including that subbar thing, all the magic happens, and he's good to go.
Yeah, this could be something for ports people, because it's much easier than, say, servers, whatever port name, and then start, status, restart, other than running some crazy other syntax. So this might be a good starting point.
Yep.
All right. Thanks for that. We also have a brief history of Z over at sorcerer.io.
Yes, for the SED, or the stream editor.
Yep, can do a lot of things.
And its better-known sibling grep are stalwarts of the Unix command line, and they have around nearly as long as Unix itself. If you spent any time at all as a software engineer working with Unix, you're certain to have used them. The story is interesting, though, not least because it can't be told without mentioning many acknowledged giants of computer science. It's especially interesting when you interpret it in the context of all the other emerging parts of the nascent Unix ecosystem that were also in motion at the time. So first, a little context, and I'd be wrong not to mention that we've sourced much of this from the historical sequence of events from Michael and Rhonda Haubin's Netizens Netbook. Of the key milestones in the early years of Unix, the invention of pipes, where the output of one program could be the input of the next program, was seminal. The ability to use the command line interactively during the or directly to articulate the ideas of functional composition delighted the early Unix designers. Pipes were first implemented in 1972, and their usage was hardly changed since then. For example, the output of the ls command is often piped to make it easier to read.
Yeah, this is the typical use case. Cool. Yeah. So check out the blog post. And
yeah, there's a lot of detail. I'm just trying to see if I can find the tidbit I'm looking for. But you can see in this example, they're echoing the file name and using sed to replace the file extension with .txt for all of them.
Yeah, we're using the regular expression.
But yes, there are 25 different sed commands available, and there's lots of interesting history here. I'll have to come back and read more of it later.
Yeah, there's a whole book about Z, so there's a bunch of stuff you can do with it. But yeah, this is a good intro, and for the history folks, they can look that up further. Our last item for this week is Flame Graph, explaining why does my AWS instant boot so slow.
Yeah. So this is a little teaser from Colin Percival's upcoming talk at some conferences about making FreeBSD boot faster and also profiling what's causing the delays. So you can see, we see the kernel here starts up. That basically accounts for all of the time. But then there's a small function here called hammer time, just from back when the AMD 64 architecture was called the hammer. And then it goes into this function, machine independent start. And you can see that the things called from that are all of the time in startup. And we see in hammer time, actually, most of our time is actually spent in the delay routine, just waiting. But we can see once we start the startup function, we init the memory. And when we init the CPU, that involves some sleeping and then printing out some stuff. And then we see the next big one here is starting the APUs. So that's your additional CPUs. Then a bunch of small things. And then we start the function configure2, which we see takes up most of the time. And it actually spends its time attaching the Nexus device, which then attaches all the other devices. We can see it spends a little bit of time printing stuff to the screen, but spends most of its time walking through the ACPI table and attaching all the different devices, including, our PCI devices, the keyboard device, the mouse device, etc. And we see a bunch of his time ends up being spent sleeping. And then for adjusting the clock, a bunch more time spent sleeping. If we can reduce some of those delays, we could probably shorten the whole boot time.
Yeah, small things can make a big impact with you waiting for devices to be initialized and text scrolling down, waiting for your login prompt to appear.
Yep.
So yeah, I definitely look forward to his work and the results that pretty much can benefit anyone on running FreeBSD. Yeah, so I definitely am excited for his results.
Yes. This week's feedback segment is brought to you by Tarsnap. Head over to tarsnap.com/BSD Now. Yes, in case you didn't make the connection, the Flamegraphs are from Colin Percival, who's a FreeBSD developer who started Tarsnap.
Yeah, and I mean, Colin Percival is the best. So he donated the whole revenue he got from Tarsnap in December to the FreeBSD Foundation, which we're grateful for. He hasn't done this just once. He did this in previous years as well. So this is just super nice of him. He's using a lot of FreeBSD in his infrastructure in Tarsnap. He's also a FreeBSD developer. So he definitely is the person to run such a service that is an online backup for the truly paranoid. So,
yes, like in particular, Tarsnap wouldn't be possible without FreeBSD, and that's why he makes the donation.
Yeah, so you always want to have backups, of course, and you want to make them securely, and you want to store them somewhere outside of your house, because if your house burns down, the whole backups are gone, and you want to retrieve at least your social security number or some other information that you have stored. So let's store it in the cloud, but secure it there securely. So you're the only person having the key to the decryption, and no one else can get to them. And Tarsnap makes that easy, providing you with all the tools that you need. And if you know how to use Tar, then you know also how to use Tarsnap, and that makes it easy to create the backup and decrypting it when you need the files back.
Yeah, it gets segmented, deduplicated, compressed, encrypted, and signed before it leaves your computer, so that no information about your files are leaked to the cloud. So, you don't have to trust Colin. You don't have to trust that Colin's not being, tortured by the U.S. government. You just have to trust the source code that you can read with your own eyeballs.
Yeah, that's why
compile it yourself. It's the only way to back up safely. I'm not sure why it hasn't caught on more.
And it doesn't cost that much, because you charge your account there with $5 initially, and that gets you a lot of the disk space already. And if you need more, then you provide another $5 or $10. So it doesn't cost that much, and most of the stuff that people store there isn't that big. So there's a lot of leeway where you can go with these $5 for years sometimes. All right. We're going into our feedback and questions section for this week, starting with Jeremy about replacing a drive in a Z-pool. So he writes, first off, thank you for all the good shows, and please keep up the good work. Yeah, will do. Thank you for the feedback. So his question is, it comes with is having a small home server running Ubuntu with ZFS on his storage drive. Just to stop you there, he tried FreeBSD first, but he had the wrong card, and there's some other driver problems, and this is the state that he's in currently. So back to his question. He has 4 drives in there with 2 mirrors. 2 of the drives are 2 terabyte. Of the other 2 are 1 terabyte. He got a gift of 2 4 terabyte drives and wants to replace the 1 terabytes, but doesn't have enough room for even one more drive to swap out. He asked, can I connect one of the 4 terabyte drives with a USB and Z-pool replace one of the 1 terabyte drives and then install both 4 terabyte drives in the server and then repair the mirror in ZFS? He has seen a couple
usually it will slightly depend on the USB device, but most of the time, yes, that should just work.
Mm-hmm. Yeah, so he's seen a couple of guides online on how to do this, the proper commands. So he was just asking whether this is possible. USB might not be the fastest one to move all the files over, but it work. It's for the pool doesn't care, and if you just have it in there as a replacement before you get the bigger drives in, I don't see any problem with that.
Yeah. Also, if you have enough SATA ports, I know what Dan did while replacing on some of his was actually plug the 5th drive in to the SATA port with like the side of the case off, just to let it sync over, like finish the zoo pool replace, and then he could swap out the drives. But if you don't have enough SATA ports, then you can do it over USB. It'll just probably be 4 times slower or so. But it's running in the corner. Doesn't matter if it takes 1 day or 4 days, right?
Yeah, it's if you have the time, then that's pretty much no problem.
Yeah, I think Dan even has pictures of his server on dan.langil.org of his server with a bunch of hard drives hanging out of it as he was swapping out the drives for bigger drives.
Yeah, so easy enough. Yeah, so good luck with your drive migration. And for people who think about this, remember, while the drive is replacing, you can still access the data. It's no downtime. It's just ZFS as it's supposed to do its stuff. All right.
Yeah, in particular, if you're using zoopool replace while the old disk is still there, you're also protected against the failure of the old disk or the new disk because you haven't actually reduced your redundancy. Whereas, if you have 2 drives in a mirror and you pull one out and put the other one in and do the resilver, if either of the 2 drives in the mirror dies, you don't have a copy of everything anymore. But if you temporarily basically have 3 drives in the mirror, even if both the new one and the old one die, the third one is still fine. So, yes, if you do it online, that's better.
The speed might be a little bit slower, but you still have the files there.
Well, actually, for resilvering, if you have 2 drives in the mirror online, you can read from both as well, and you could actually speed up the resilver.
It's just ZFS. Yeah, I love it. All right, on to Tim with his next question. He wants to keep galley keys through reboot. So he has a short message sent to us. He writes, I have a VPS instance with ZFS on galley, and while I don't mind pulling down regular patches and updates or even the downtime a reboot entails, it's a pain to log into his management interface to gain VNC console access and re-enter the galley password. However, at the time I type reboot, the system already knows his description galley key because it's currently in use. So is there any way to preserve the galley key through a warm reboot or so that he doesn't have to use it in the console?
No, not really, because that wouldn't be secure. Even with a warm reboot, you're ideally, the memory is cleared, so there's no persistence, and you don't really want to write your decryption key down on the disk somewhere, because that would obviate the entire point of.
Yeah.
Plus, depending if the disk is, say, an SSD, then even overwriting it doesn't ensure that the data is actually properly destroyed because of the remapping that happens in an SSD. So no, it's not really a solution to that.
Yeah, but there's caching of galley keys if you have.
That's so you don't have to type the same password 4 times.
Yeah,
that does not solve the problem of.
Yeah, if you reboot, then you still have to enter it.
Yeah, but also, I'm supposing the reason you are encrypting your VPS instance is because you don't want people to be able to read it. So anything that reduces the security. It's like, well, you might as well just not galley encrypt your VPS then. Because otherwise, they could hot reboot your machine and log into it in SQL user mode with the disk decrypted or whatever, but nothing else running and get your files or whatever. And then what was the point of encrypting it in the first place?
Yeah, so err on the side of security in this case. And hopefully you don't have to reboot that often. But in those cases, you just have to bite the bullet and still rest easy.
Eventually, we hope to have support for like a USB dongle, but that doesn't really help you in the case of a virtual machine somewhere far away.
Yeah, but there's work going on in galley. That's cool. We had or I wasn't there, but you were in the galley session at the BSD Camp Dev Summit. But there were some cool ideas thrown around, so I see
I just need to find some of that, loose spare time in the couch cushions or whatever and do it.
Or start Google Summer of Code and make it a nice little entity.
Write out the idea more to do that, but maybe that's an idea.
All right, yeah, so thanks for that. And we'll continue with Brian's question. He writes about mixing 2.5 and 3.5 drives. So he starts with, I'm a big fan of the show and have fallen behind. Forgive me if this has been asked before. That's okay. So he's building a new FreeNAS install and has a question about mixing the drives. He has lost data before due to a failed RAID 5 rebuild. A second drive failed during the rebuild process with a fresh drive. He's not even thinking for a stripe of mirrors yet. Mirrors seem simply compared to RAID Z2. He wants to set up a 3-drive deep mirror alone. For this exercise, he's using 7,200 RPMs, 3.5-inch drives. He has some 2.5-inch drives available to swap in the event of a failure. And he's using the stock case of an HP 6000 Pro machine with a 5.25-inch
bays. 3.5-inch floppy bay and 2 internal 3.5-inch bays. Mm-hmm. He says Newegg has a deal on a 4X 2.5-inch backplane thing. What if I use the backplane to hold 2.5-inch 500 gig drives and the FreeNAS host OS, then use a 3.5-inch drive for the third drive in the mirror? Since the 3.5-inch is faster, the data reads will almost always come from the 3.5-inch drive. It doesn't quite work that way, but for IOPS and stuff, it's going to stagger them across all three anyway, so it will be faster just because there are more spindles rather than because the one drive is faster or whatever. But yes, ZFS doesn't care what size physically the disks are and so on. Do remember, though, that your writes have to go to every member of the mirror, so the writes will be the speed of the slowest drive.
Yeah, that's the trade-off that you have with this kind of mirror. But you have redundancy this way, and if something fails, which we hope you don't experience again with while we're rebuilding your RAID, then you still should be able to retrieve all the data.
But yeah, with 4 2.5-inch drives and 2 3.5-inch drives, you can sort those into the two groups however you want, although what you proposed looks good. And yes, that'll work fine. Yeah, there won't be any problems mixing the sizes. Should work just fine. I have 2 VDEV RAID Z2 at my home NAS. That's 6 3-terabyte drives and 6 5-terabyte drives.
Mm-hmm.
And some are on the SATA on the motherboard, and some are on a LSI controller. It all just works.
All in the same pool or in different pools?
One big pool.
Ah.
It's like the whole point of ZFS to have one big pool, right?
Yeah, but not with like 100 drives or there's
my biggest
don't
pool
you break that up
currently. No, why would you do separate VDEVs, but it's all one pool.
Yeah, that's what I meant. But you won't have a.
You said different pools, which doesn't mean the same thing.
Yeah, so if I would have more drives at a certain point, I would figure out I should break it out into 2 pools to not have to buy that many drives overall.
You're
still considering
confusing things. No, you don't want separate pools, because then the free space, you end up with like 10 terabytes of free space in that pool and 10 terabytes of free space in that pool, and you need 15 terabytes of space, and you don't have it.
Yeah, right. You could combine those two.
You're confusing pools and VDEVs, which aren't the same thing, right? A pool is made up of many VDEVs.
Provide the redundancy.
Right, but you stripe many VDEVs together to get more space.
Yeah, so that's the... Yeah.
So like on my home one, I have 6 3-terabyte drives as a Z2, and then 6 more 5-terabyte drives as a second Z2 in one pool. So I get all the free space.
That's striped together. Yeah, okay.
Yes.
That makes sense.
On my biggest server, I have 48 6-terabyte drives in 4 different VDEVs.
Okay. That's not what the typical home use would be. But
and we ordered 12 more for that machine from IX yesterday, and they should ship today and be here next week.
Okay.
So yes, that pool
All right. Yeah. This is a big,
is
much bigger.
260 terabytes. And it's already 82% full. Hence buying more
They
drives
can't
for
ship
it.
those drives quick enough. All right. I think we answered this question. Cool. Thanks for sending that in. And last but not least is ZFS swap on FreeBSD. Charles writes, hello, Alan and Benedict. First of all, thanks a lot for a really great show. Two of you do a phenomenal job. Oh, thanks for the feedback. I got a question primarily for Alan regarding ZFS and swap on FreeBSD. So back in 2011, when he first started using ZFS on FreeBSD, on 8.1 release, roughly, he initially installed it with his swap space in the ZFS pool. Sometimes the system would hang and be entirely stuck except for responding to pings. He discovered that this was likely due to his swap space being located on the ZFS pool, and the explanation he found back then went something like, ZFS needs to allocate memory to do I/O operations, but the swap space is needed when there is no memory available, and ever since then, he always used a pair of regular FreeBSD swap partitions in a gmirror setup to handle the swap. So recently, he has been seeing some people say in the FreeBSD forums that this is no longer an issue, and seems to remember that Solaris-based systems use ZFS for swap space. However, he also has noticed that the FreeBSD installer in 11.1 release uses regular FreeBSD swap partitions for swap, even when selecting to use ZFS. It would be really nice if we could clarify the current state of ZFS and swap, and how the problem has been handled if it hadn't been solved already.
Yeah, so I still use gmirrored raw swap partitions, and so does the installer. Swap on ZFS definitely works better than it used to. I haven't used it much personally, so I don't have much personal experience with it, but my understanding is that it's not a problem anymore. The downside is currently FreeBSD doesn't support crash dumps to ZFS. Right, so if your swap is a zvol on ZFS, you can't crash dump to it because the ZFS code's basically off during the crashing phase. So there's the advantage to doing regular swap in that case is that you can crash dump to it, and so on. There's a way to do ZFS, crash dumps to ZFS, and it works in Solaris, and there's a high-level design of how you would do it on FreeBSD. It's just not actually been done by somebody.
Yeah. But keeping it on a separate partition, if you already know how big your swap is going to be, it doesn't take that much away from
although there are many, many advantages to swapping on ZFS, including being able to change the size of it easily. I've just not done it.
To-dos for the future. But you should be fine with a separate swap partition. And since you've been running this system for a while, I think you updated all
both
these.
Work. Generally, in a production like dash release, you're not doing crash dumps very often anyway. So yeah, swap on ZFS is probably fine. I should ask Sam a bit about it, because I know at one point he was looking at it because the swap partitions on the servers he was using were too small. And so he was forced to do it that way, although he really wanted to do crash dumps, and the fact that doesn't work on ZFS currently on FreeBSD was a downside for him.
Okay. Yeah, so people shouldn't be afraid to use ZFS and keep your swap big enough, which is always good in case there needs to be dumping made. All right,
but
that's
swap on ZFS should work.
Yeah, totally. So we should just keep it a little bit more in steady and making sure that it doesn't crash or something.
Mm-hmm.
All right, that brings us to the end of the show, but we won't leave you until we mention the submission deadline for BSD Can, which is January the 19th, so pretty much next week.
Yeah, the end of next week. So, Friday, right? Yeah, Friday of next week.
Yeah.
So, submit to BSD Can. It's not hard. You go to the website, you sign up, it's good. You type maybe this much text or so, not that much, just explain what you're going to talk about, why people are going to care, why you're an expert at it, or why you know about it, or whatever. We'd really like more talks by users and sysadmins. Developers want to hear from not developers. Also, BSD can. It's like half not developers. Not developers want to hear from other not developers as well. So please, first time speakers, fine. Just submit. The
Could be your home setup.
It gives us more to pick from.
Yeah. Like anything where you use BSDs in various interesting ways at home or at work or in a production environment, in any crazy environment, anything that's interesting to an audience. BSDCan is a good conference to present your work there. Get a lot of BSD folks there.
Yes. There are 3 or 4 talks going on at once. We need to fill all the slots, so we need lots of submissions.
All right. That pretty much wraps up this episode. Keep your eyes open for the next episode where we cover more about Spectre and Meltdown and the other BSDs. And if you have anything found on the internet that might be interesting to cover in the show, then send it to us at feedback@bsdnow.tv, and we'll cover it in a future episode. Thanks for watching.
A number of things like that. In particular, we're recording a week ahead starting soon to cover the fact that we're both gone for FOSDEM. So that means we're kind of stretching, finding enough content. There's plenty of things happening. We just don't know about all of them. So if you email us some extra stories this week, we'd really appreciate it.
Yep. Or if you have questions for our feedback and question section, that's also...
Yes. We were already behind. We're very low on questions, and we're doing an extra episode early. So more questions. All of the questions.